along with everything else. Okay, and then this next section is on aneurysms. When you're coding an aneurysm, basically you have to figure out how they are dealing with it. So one thing that they commonly do is open them up and cut out the portion of the aorta, whether thoracic or abdominal or wherever it is. They cut out that portion and then put a graft in to hook it back together. Okay, that's going to code out as a replacement. We took out the normal body part and we put in a graft to replace it. Okay, so that will be replacement. You can see some examples of that code at the bottom. And you can see, is it going to be replaced with autologous tissue, synthetic, non-autologous, or zooplasty? Remember, that's our animals. It also tells you here that if the graft material is animal and there's no device value for zooplastic, then code it out as non-autologous tissue substitute. So that's one way they can deal with aneurysms. Okay, just cut them out, get them out of there. Okay. On the next page, they talk about ear, which is endovascular aneurysm repair. I love it when they do stuff like this because maybe that computerized coding will never catch on. Because if you say they resected the ear, it's going to think they took. Anyway, in this one they mean endovascular aneurysm repair. And here what they're saying is they're going to restrict that vessel so that it cannot expand anymore. And so the question is, are they doing it with an intraluminal device or graft, like a stent graft that they're putting in there? Or are they doing it outside? They're wrapping it, or they're putting some sort of clip or sleeve on it so that it can't expand that way, in which case it's extraluminal. But the root operation is the same. It's restriction. They're trying to narrow that lumen and not let it expand with the aneurysm. So restriction, then the question becomes, is the device intraluminal or extraluminal? Okay, so aneurysms, think replacement or restriction. Okay. Then sometimes we spring a leak. That's not good. Those are called endo leaks, and that's where the blood flow has gone back into the aneurysm sac. It's outside of the intraluminal graft that they put in. Okay? So in that case, it's going to be a revision. Okay, and you're going to code it, the revision of the intraluminal device in whatever artery and percutaneous approach. They're also pointing out that a stent is a device, but staples are not. Staples are considered supplies and integral to the procedure and not coded. So when they go in there and staple that stent graft, you're only going to code the graft, the revision of the graft. Pseudoaneurysms or false aneurysms are actually where the blood is leaked into the surrounding tissue. It's actually outside of the arterial wall now. And that's not really an aneurysm, so those code out to the root operation repair when they just go in and suture them. Or, of course, they could make it more difficult. They could go in and clean out the blockage in that graft, which would be an angioplasty. And that's repairing that graft, so that's going to code out to restriction. It's going to code out to revision, revision of that graft. And then sometimes they might stick in another stent graft to support that, and that's going to be a supplement then. Okay, so you might have repair, where they just suture it, or you could have revision and supplement. So let's look at top of page 437, where it talks about the pseudoaneurysm. It says it's a complication of a previously placed graft. Tells you at surgery a stent graft was deployed inside of the existing graft to reinforce it and prevent recurrence of the rupture. So this is where it's telling you it takes the two codes. The revision to show that the previously placed saphenous vein graft was repaired, and then supplement to show that they put in that additional stent graft to reinforce the existing graft. Okay? Again, they could also put in a pressure sensor monitoring device, which you would have to code as well. And then it talks about branching or fenestrated grafts. There's nothing different there. These are special grafts that they make up for each individual because they apparently are not anatomical candidates for the regular standard grafts. So they fix these so they'll meet that person's needs. And sometimes they have holes in them, I think, so they can attach them. That's where the fenestrated part comes in. But they code out the same way. It still codes out as restriction, still codes out as an intraluminal device, so don't get hung up on that. And then embolization. Who remembers talking about embolization before? Do you remember what you had to think about? Embolization, remember we said maybe they would do an embolization to cut off a tumor versus embolization to restrict an aneurysm. So you have to know what their intent is. Are they intending to totally occlude the vessel, which is what you'd see with the tumor? They don't want blood getting in there to feed that tumor. They want it to die. Okay, versus an aneurysm where they don't want to cut off your total blood supply. They just want to restrict it. So when you're doing embolism, think, am I doing a total occlusion or am I doing a restriction? And then esophageal varices are enlarged veins in the esophagus. And a lot of times they will go in there and band those to close them off. So your root operation is occlusion of the esophageal vein. You have now been through the entire circulatory system. So let's try doing some coding. On exercise 438, page 438, let's try doing number 4. Number 8, but I want you to break 8 into 2 problems where they have that broken part. Code those as 2 separate admissions. Okay? So make a line after permanent cardiac pacemaker in place. That'll be 1 admission, and then the bottom half will be another. And that one's going to be hard. That second part is going to be hard, so I would do the other ones first and then come back to that one if you're having trouble. Okay?